Let's start with today's problem. Is that okay? Given an pre-order and in-order traversal of a binary tree, write a function to reconstruct the tree. Okay, so we have given the pre-order and the in-order traversals. We are supposed to reconstruct the tree. So we have the traversals in a list. This would be the pre-order and this would be the in-order. We have been given with the output should be the tree. Okay. Let's just copy all this question. Fine. So what we would get started with is first we understand what is the pre-order and in-order traversal. So pre-order traversals would be something like pre-order, right? So pre-order traversals would be something like first it would be the root, following which you would get the left child, then you would get the right child. Right, so does that make sense here? So the root would be in this case A, so you would have A in the pre-order, following which you would have the left child is B, so yes, you have B. Then you would have the right child, that is C, that comes after the B subtree, comes over here. Okay, and the in order traversal would be something like we would start with the left child, following which we would have the root, which is then followed by the right child. Confirm. So here left child would be B A C, but since they're all subtrees, you would have them something like D B E. Then you would have, this would be the entire left subtree. Then you would have the root A, which is then followed by the right tree. In the right side also we should follow the same logic of left, root and right, so it will be F C G. Okay, we have that. Okay, so we will be able to traverse it. So now let's just draw it for confirmation. So if we have, so we would have A B C. So the in order traversal of this would be something like left, root, and then the right. So this would be something like P A and then C. Okay, this just, how do we reconstruct a tree? We know the logic that it is coming from the left, then the root, and then the right child. Okay, how about what can we use for with the pre-order? They have provided us with the pre-order also, right? Pre-order would be something like the pre-order would be, so we just call it as pre-order. So pre-order would be something like root would come to the left child, then to the right child, right? So this would be something like A, B, and then the C. Okay, so we can, okay, for reference of root, we can use the pre-order. Like this always indicates this is the root, then the next would be the left side element. If that can also be a root if it is having a subtree in the bottom. And then the third one would be the right side, right? So this would be the left, this would be the right, and this would be the root. Okay, this would be the left. Okay, okay, this kind of makes sense. So we can use the pre-order traversal to find out the root, the left and the right. We could use the in order to find the subtrees, like this would be in everything up to B would be the left subtree and everything up to C would be the right subtree, right? So yeah, everything up to B would be the left subtree and everything from right C would be the right subtree. Okay, okay, let's assume that we have been given these two arrays as our traversals. Let's try to reconstruct the tree that we need over here. So to begin with, let's start with a single node. So let's say class node, right? This node consists of the init self, and we have some data. This data would be the string, basically like ABC or whatever it is. So we have self dot data is equal to data. Then we have self dot the left child, but now we'll have it as none. Then we have the self dot right, which is also none for now. Then let's say that if name equal to main, if name equal to main, we would need to, okay, first we'll say in order traversal is equal to what is my in order traversal? We'll call it as in order itself. In order is equal to, initially let's say we start with a single node itself. Preorder is equal to a, right? In both these cases it will just be a single node. Okay, we need a tree as an output, where we say that, let's say we have a function called as reconstruct tree. We will pass the in order and the preorder, right? We'll pass these two and expect the tree to be created back for us. Let's then print back the tree. This would be the first step. Reconstruct this. Perfect. Okay, so we have this. Let's now get back to the function which creates this. Create, increase the font. Okay, def reconstruct tree, right? Reconstruct tree, it accepts two parameters as of now: in order, preorder, right? Okay, this should return back a tree. Tree is nothing but a object of the class node, right? Like it will be the root, pointing to the root. So we'll say that return node. Now we'll create the node equal to node, where I need to pass the data. This would be a. So I would need to tell at index 0 from preorder. Like we need to look at preorder to get the indexes, right? Because we need to get the root value. So to get the root, I need to look at preorder, because inorder is first one. We don't know where the root would be in the inorder, right? Because the first element might be the left subtree. The second would also be part of that left subtree also, right? So in this case, we have to refer to the preorders. First element always in the preorder would be the root, correct? Because it always goes from root left right. So root left and then right? So this kind of makes sense. So what we will do is we need an index pointing to where we are with respect to the preorder. Let's say this is the root in, not root index, we'll call it as pre-index, right? Index is equal to, initially it will be 0. Inside this function global tree index, we can update it later. For now we'll go with this approach. Preorder, I think preorder, anyway spelling is preorder. Okay, preorder. So preorder of my tree index, right? Tree index would give me the node, and I would print back the node, right? Let's see at least if this one works. So let's open up a terminal and then just type Python. Oh, okay. 3. Oops, it's not installed. 3 Windows. I just install it right away. 3.8. Specifically, we are looking for 3.8. Yeah, if we can get this 3.8.10. Do we have a Windows installation? Yep, Windows installer 64-bit. Just install it quickly. Install that. As soon as that's completed, mhm. Okay, we'll come to, still this gets installed, we'll come back to our function. So we have a node, we have the left. This should ideally, when you give a, it should return back as single node, that is the tree. Next we can try with the ABC. Okay, so let's again go back. Python space what is our program problem 129. Okay, it's not printing because do we actually have it? Oh, maybe it's not getting in. Python 3.8. There's a problem. Python is not recognized of command function or executable program spelling. Okay, Python 3. Okay, let's go check the command line. Is there Python 3.8? Python. Oh, just Python, I guess, right? So we just give Python. Oh, this terminal was not restarted, right? So it might not know that we have installed Python. So we'll restart the terminal. Once again, let's just type Python. Oh, it's not picking it up. Okay. I've installed Python redirector. I don't know. I don't want some different terminal. I just need the PowerShell. Okay, let's try from PowerShell. CD daily. We have. Oh, we need to reopen it in the same location. So we'll go back to the program. We'll go to the PowerShell. And then we will run the program. Python. We have Python. Yes. Okay. So we have Python. We type Python problem. Okay. Oh, we are printing the node object. We're not printing the value, right? Let's try to print the value of that. So to print the value of this, let's override the str method. Self return. What do we return? We can only return data, but if it contains a left and right, then you will need to return that also, right? So we will say self dot left followed by self dot data, should be in brackets, then inside brackets of self dot right. Right, in this case there is only single, like this would be none, this would be none, so this would be just data here would be a. So ideally we should be seeing a here. Run that. Okay, we are seeing none hyphen none, right? Let's try to remove the none and start with empty. Right, so we start with empty, we should be receiving just a over here. That kind of makes sense. So now we have a function to give us a root node and we have just one node over here. So we're partially in the right direction to get the solution. Okay, so now we need to go to the next step. Let's assume that we got the next equation was, what was that? We went with BAC, right? So if we go with BAC, this would be the BAC, and this would be, what is a preorder? ABC, because it will be root left and right. So we'll go with root left and right. Perfect. So we are going with that. So step one, when we call this function for the first time, it would hit, we would get a as a root, and we are returning it back. That wouldn't make sense. We need to then iterate over the left, like so that we construct the left tree and the right tree, right? For that we need to, instead of iteration, we need to recursively call ourselves. So we need to say that if we are going to recursively call, we need to say where we are going to start and end, right? Because if I'm calling this function once again, how do I know that I have to start at B? Like I have to look at the left subtree or the right subtree. I need a way to start and end it. So for that, let's keep some counter variables. So let's say we have a variable start and end. Initially, our start would be equal to 0 and end would be equal to length of preorder or inorder. It doesn't matter because both would be the same. And length would give me +1, so I'll just, because length would start from 1 and we would be indexing it from 0, so subtract it with -1 over here. Okay, so for the first right, the first recursion call, what would happen is we would start with the two arrays in order preorder, and yeah, and we would start at 0 and go up to 3, right? 3 minus 1. Okay, so that would be 2. We would go up to 2. So this would be the start, this would be the end. And then when you hit that, what would be in order? A, B, A, C, right? B, A, C. And this would be A, B, and C. Okay. First step is I need to, in that case, say that my left sub tree is equal to reconstruct the tree in the left hand side with the same in order and the preorder, and this time start at you need to start at 0 only. Okay, so start at this starting value, that is all right, and end at don't go through the entire tree, you're only concerned on the left subtree, right? So I would need to tell that go up till A, correct? I don't need to go A and C because this would be the right side, and A already we have because we already got the root. When we just check the index, this value 0, we got to know A is constructed. So we just need to construct the left hand side till this. So that means we need to know where does A lie on the in order tree, right? In order, this would be the pre-order, just for reference, pre-order. Rather we will keep it in rows, that way it's easy, right? Yes. Start, end. Perfect. Okay, so this makes sense. Right, we start at 0, we're going. Initially we got to know the first root is A, right? Now we are trying to construct the left subtree and right subtree for A. So we are going to say that, hey, again reconstruct a tree with the left subtree as your what you need. In this case we have only B, so we need to find out at what position A lies inside my in order, right? So let's say we'll call that variable as root index. Root index is equal to in order dot index, right? That's the function to get the index of an item. Let's just verify that. Python a I in order is equal to, let's say we have 1 2 3, no, we'll go with something else, call it apple, banana, oranges. Okay, so if we say in order dot index of, I want oranges, I'm expecting 0 1 2, 2 should be my answer. Oh, okay, this would be good for us. So now we will say, hey yo, find me the index of the value A. How do I get A now? Okay, it's already in the node, right? Like if we access node dot data would be A, so we get the root index. Okay, so now we can say that start at 0, this would be the starting, and end at root index, like go up to index number 1, correct? So there will be 1, so root index, say the ending, right? End equal to this and start equal to this. Should it go because this is inclusive, right? Like root index means 1, it will try to pick up till 1. We need only till here, like it should not be inclusive, so let's say it should be negative. 1. So that way it will go up to only from B up to A. A is not included here. Okay. Similarly, we need the right subtree. Right subtree is equal to reconstruct the tree from the Inorder, Preorder. This time start from I need to start from A and go up to C or till the ending, right? So which means my ending is whatever end that you have passed, the length of the array or whatever it is. But my start would be something different. Start would be something like it would be root index. It would be inclusive, so we need to start from root index plus 1, saying that skip A and take everything from A right hand side onwards. This makes sense, right? Okay, so in the first recursion call we call this, then what would happen is inside the first recursion call itself, when we go to the left subtree, the recursion call would again get invoked. These remain the same, right? This would remain the same, but my starting would be 0 and my ending would be up to where does it go? Root index of what is it? A root index value. Root index value over here is, let's just print that out. Root index would be something like, where does A stay? A stays at position 1. So root index would be 1. So my starting would be 0 and ending would be 1 minus 1, which would also be 0, right? Okay, fine. So when I get this again to the same function call, if these were my parameters, what would I do? I would create first a new node where I would say that, hey, you have to create a node with the pre-order. This value should increase because now we are in the next, we have already crossed our first root value. We are going to the next root value, right? In this case, it would be the left. That makes sense. So we need to increment this. Where do we increment it? We increment it every time we access that index, right? So we create a node. We would initially, first time when the first recursion call occurs and we are searching for A, tree would be, this tree index would be 0. We would go check preorder's 0th element, that is A. We create root is equal to A, and then we bifurcate the trees into the left subtree and the right subtree based on the position of A in the Inorder tree. But when we come to the second recursion loop, that is basically the left subtree, that time we should look at what is my next root element, basically that would be B, correct? The position of B is indicated by the tree index. Okay, that makes sense. Fine. So now we have this. So we got B's index node. We created a node with B as a value, but B does not have any child, left child or right child, right? How do we get to know that? What do we have? We have preorder, Inorder. We have start and ending. Okay, if start and end both are equal, right, that means that it is just a single node. Basically we are at the leaf child and there is no left or right subtree. So we'll go with if start equal to end. In that case, return node. That makes sense, correct? This would indicates the leaf node. Makes sense. We are looking at preorder indi. Actually, we use this for use to define root elements. Basically, it's root left, right, correct? In preorder, we go with root left, right. But when we go to the left subtree, the first element would be the root of that left tree. If it's a single node, it's just a single value, right? So that's why we are using that as our reference. Okay, so we find the leaf node, we return node. No, we need to return the node value. So we return the node. So left subtree is completed. Then we go to the right subtree. When we come to the right subtree, let's say this, right? So we'll go to the right subtree, right subtree. What is my root index? right now the tree index would have incremented to from it was initially 0, then it became 1, now it became 2, tree index 2. I think we can even keep track of that. Tree index will be initially 0, right? Then here it would become 1, and now it would have incremented to 1. Initially it was 0, then after the first recursion call it would have become 1 because it is post increment. So it's 1, then it is 2, now it would have been 3, right? So now we go to the pre-order array. Yeah, this is post. This is just to indicate post. That means after we access the array, what is the value of tree index? So we accessed in the left tree and the index was 2. So we come here. Pre-order of 2 would be 0, 1, 2, right? So 2, we'll say, okay, C is my new node. I will create a node with value as C, increment it to 1. So hence it becomes 3. Then I check whether it is starting equal to ending. Yes, it does look like that. Oh, I did not write what are we starting with, right? So let's start. What are we starting with? Starting over here was root index plus 1. Root index was what? 1, right? Root index was 1 over here. So we started with 1 plus 1, that was 2, and ending would be the default ending when we started the entire loop, that would be 2. So we ending with 2 only. So that also we starting, because it's a leaf node, both of these are same. Okay, so we start with 2, end also with 2. So we are going to return back the node. So we are now going to again recursively call it in the right subtree. So ideally this should handle the BAC also, right? BAC. Okay, save this. Let's come back and run the function and check. Okay, we are somewhere having a variable pre-order. Run it again. Okay, we start with only A. Why is that the case? Started with this. I saved it. Yes, it's saved, right? Length of Inorder is 3 minus 1, 2. Reconstructed is okay. If it is not coming in the left hand side, that means we are missing something. Let's come back and check. Are we calling this function? Okay, why don't we just initially just print what we are getting? Print. What we are going to print is we are going to print the reconstruct tree. We can put it here. Yeah. So we have to print the start, end, and the free index before access is right. We need to print that. So we go with start, then we have the end, then we have the free index. Perfect. Save this, come back to our terminal, and then run the code. Okay, you start with 0, 2, 2. This matches our let's clear this up and run it once again. Okay, we start with 0, 2, and 0 is our tree index, matches. 0, 0, and 1, that also matches. And this is because this post it is written 2, but okay, this kind of matches. So we are iterating over the entire tree correctly. Now the question is, why is it not printing the data? It should have printed left, right? It should have printed P when it goes to left. I should get that. Oh, I'm not assigning it back to the node, right? That makes sense. Let's say node dot left is equal to that, and here it is node dot right. Right? Save that, run the program once again. Okay, we have B, we have A and C. Okay, this makes sense. This kind of gives us what we need. So now let's go back to the problem statement where they told we have this would be the pre-order traversal. So let's copy that and paste that over here. We have A, B, D, E, C, F, G, F, G. Okay, A, B, D, A, B, D, E, C, F, G. On over here. And what are they given for the Inorder traversal? DBE. Okay, we'll paste that over here. We have D, sorry, comma, we have E, then we have A, we have F, then we have C, and then we have G. Okay, save that, run the query again. So we have, oh, since we are printing back the in order, right? Basically what we are printing here is the left data right. That is nothing but the left root right. Left root right is nothing but the in order traversal. So if our print statement here matches with the in order traversal, we are kind of correct, right? So print, this is just to verify, main the in or in order traversal is in order. Okay, save this, come back to the terminal, clear it up and run it once again. So we have D, D, B, B, E, E, A, A, F, F, C, C, G, A. So we were able to reconstruct the tree. This can be printed in any manner. It doesn't matter. Since we are constructing it in order, we have it like this, but this tree is what we need. Okay, I think that should be it, right? Like we have created the tree, we have passed the requirement of should return the following tree with the things. Yep. Okay, we can add a little bit more checks here to ensure that this recursion doesn't a mistake keep going on in any case. Ideally it shouldn't, because all of the indexes are based on the length of the in order array, which matches with the pre-order array. Correct? Yeah, we could have a check here. If in order doesn't match with pre-order, then don't even get started with the program. But yeah, this should be the solution for this problem. Okay, bye bye.